We're here at this beautiful house that's ready to harness the power of the sun. We just checked out where all of our equipment is going to be installed, making sure that what our engineer plans say is true to reality.
Yeah, definitely.
And our next step is we're going to hop up on the roof and start installing the racking. And then the solar modules each wire individually into an optimizer. And the goal of an optimizer is three main things. First one, National Electric Code compliant rapid shutdown features. You should be able to press a button and the whole thing should shut down. And then the second thing that this does is shade fixing. So for example, that chimney pipe has some shade on some, but not all of the solar panels. What would happen without an optimizer is that solar panel would have a substantially higher resistance. So if you have a constricted artery, what this does is let the flow of power kind of just ignore that one solar panel. That would let this solar panel contribute in a lesser fashion by changing the voltage to match the resistance of the string. The third thing it does is monitoring and tracking. So each solar panel will have one of these underneath it. Helpful for troubleshooting. Really easy to say all of our solar panels are connected and producing. The downside is the reason it might not be producing is because the Tygo broke. That was a joke I told earlier that got some laughs. An intelligent electrical panel. So this is the point guard load hub. It's an MID, a microgrid interconnection device. This is where power flows in from the grid and then flows out to his main electrical panel, connects his two inverters, as well as have 4 240 volt and 2 120 volt controllable circuits that we can know how much power they're using, and we can set them up for controls. So Eric's hot tub, when the grid is down, we probably don't want to be powering the hot tub. So we've told the system, when the grid is down, let's shut the hot tub off. And now Eric can go in the app, and if it's going to freeze, he could re-enable that hot tub, but then he doesn't have a hot tub wasting his off-grid energy, which could be scarce in the winter.
That building, the ground bar and the disconnection.
You gotta step.
I bought this truck so that no matter what, I'd be able to have smoothies. Yes. Side is a couple of wraps, 2 or 3.
We have the homeowners helping us with the installation.
Here at Ovanova, we believe that everybody's got to pitch in to support the energy revolution. That's why when we come install solar at your house, we'll put you to work. You can see on the wall there, we have ran all of our circuitry to come right out of the back of the wall, be hidden, tucked behind the inverters, and then go right on inside. An inverter takes a source of DC electricity and produces AC electricity. AC is what comes out of your outlets. All right, now let's get as close as we can bully these wires. We're putting in the point guard lithium iron phosphate battery. If you ever played with Lego bricks as a kid, then you'll know how to put these together because they just go right on top and snap in.
To you.
The reason that we care about storing energy is that it's not always sunny. Sometimes it might be dark, sometimes it might be cloudy, it might be nighttime. You might need a bunch of power all at once when the sun is out, or you might not need that much power at all when the sun is out and you have a ton of excess, and you can do different things with that excess. You could send it to the grid, you could find different ways to use it, but Batteries let you store it for later. It's the penultimate stage of the install. We are almost complete. We're just putting a couple final touches, final bolt tightenings, and giving Eric a tutorial. So your total intake so far in the 1 day that it's been up is 175.51 kilowatt hours. And 88.6 went to your battery from the sun.
Okay.
60 kilowatt hours went to the EVDC. That's all me. I just robbed almost half of your energy.
Yeah.
And then you can see the remaining solar went to cover your load in your house. So charging my EV and running your house, that's been about the same amount of energy.
Right.
And then you've sold 270 watt hours to the grid. I know you want to minimize that number. Yeah, exactly. This is just some of the solar on these buildings. You can see beautiful arrays, Silfab 430s, beautiful conduit work, beautiful shingles. Instead of the sun hitting your roof and destroying your shingles, the sun hits the solar panels and provides you electricity.
And then in spite of this big cloud above us, we're still bringing in 3.5 kilowatts even with that big cloud overhead right now.
And that's where the batteries are so helpful is 3.5 kilowatts. If you're reliant on just the sun right now, you might want more than 3.5. Draw from the batteries to supplement. Or the grid. Or a generator if we ever went that direction. Or an electric vehicle if it's compatible. That's where it becomes hard for a human to make all those decisions. It's like you've got the grid, you've got the load, you've got the EV, you've got the batteries, you've got the generator, you've got the beautiful shingles.